Hello, and thank you for attending today's webinar, Unlocking Innovations for Global Impact, the Power of Technology Standardization, presented by Qualcomm and Fierce Network. I'm Andrea Anderson, and I'll be moderating this webinar. Before we get started, here are a few housekeeping notes. Additional resources are available in the handouts window. If you close one of the windows and need to reopen, click the name in the top navigation bar. This webinar is being recorded and will be available on demand within 24 hours. To learn more about our speaker, head on over to the speaker bio window. And finally, there will be a Q&A session at the end. If you have any questions for our speaker, you can enter them anytime in the Submit Questions window. Now I'd like to introduce our speaker, Lorenzo Cazaccia, VP, Technical Standards, Qualcomm. Lorenzo, go ahead.
Thank you, Andrea, and thank you everyone for attending. It's a pleasure to be able to present today on this topic. So the agenda for today is going to be to cover quite some ground. So first, I'm going to try to discuss the general value of global standards in technology, why standards exist, why they bring value, and why companies work on them. Why they are complex, what are the difficulties. And then, of course, we're going to talk about a number of very specific examples. And specifically, we're going to talk about various areas where Qualcomm has a long heritage, long history of leadership. And through example, we're going to try to illustrate what does it mean to work on technology standards and try to give more substance to the principles I'm describing at the beginning. So without further ado, let's start. I think many people know Qualcomm, but Qualcomm is, of course, major semiconductor company. And general principle is that we have been working for 40 years. In fact, this is the Qualcomm's 40th anniversary in this year. We've been working to enable intelligent computing everywhere for computing, edge capabilities, and connectivity of various kinds. And this presentation, in fact, will talk about technology standards in all of these areas. Together with our long history on intelligent computing and connectivity, we have been building a major technology portfolio. This also probably is well known to many industry observers of Qualcomm. Why this is relevant? Because indeed, large number of a large share of our technology portfolio is based on standardized technology. And in fact, there is an intimate relationship between technology standards and building a technology portfolio with valuable IP. And of course, the underlying R&D that creates all of that value. Now, of course, we have to start addressing why global technology standards exist. And they do exist in a large number of areas. And there are many different reasons why, with the growth of the technology industry, technology standardization has flourished and has grown and has become a very important element of the technology world. There are different motivations. Standardization enables faster time to market. Of course, to some people, this may sound even counterintuitive, that going through the process of standardization can enable faster time to market. But in many areas, the existence of standardization enables a more efficient development, enables a globally aligned certification, and therefore allows many different regions, geographies, areas to get on advanced technology bandwagon in an easier manner. Standardization enables IP to be deployed across multiple types of devices because it enables to create a common foundation. Obviously, tends to lower development costs over an arc of time, again, because of commonality of IP across different generation of products, for example. And finally, very importantly, enables an ecosystem to grow. These are all, of course, somewhat abstract concepts. And as I said, in the remainder of the presentation, we're going to give some very specific examples in a number of important areas related to connectivity and computing. And so now we move on to understand what does it mean what does it mean to lead in standards, and why is it valuable? In many areas of technology, especially in areas that require interoperation between different discrete elements, and the telecom world is a prime example of that, where of course you have interoperation between elements that do not even touch each other physically through our physical connection because of wireless. Then a paramount need is to ensure inter-vendor system interoperability, especially whenever, as we see, throughout the technology history, whenever a segment grows, the users of that segment, they tend to want to have inter-vendor system interoperability for their hardware. Is true for the telecom sector, as you know, and is true, as we are seeing now, exactly in the last few weeks, in the computing sector. Also in the computing sector, of course, for the hardware, users of the hardware tend to want, of course, inter-vendor system interoperability, and that's where standards come into play. And then, of course, the existence of standards creates naturally a level playing field for new entrants, and therefore is also a critical element for industry competition. As we will show, standards are also a vehicle for innovation. In many areas where standards are extremely well established, like I mentioned in the case of cellular technology or Wi-Fi technology, effectively the way through which research makes its way into product is through standards. So whenever people have, for us, it's been the case for Qualcomm for a large number of years, whenever people have valuable IP in the area of wireless, in order for that idea to be commercialized at scale, that idea has to go through standards for the reasons I mentioned earlier. And like we always say, we regard ourselves at Qualcomm as creator of standards. We have a long history in participation on many standards in many different areas, and also we've been creating standards from scratch in numerous areas where we have been worked on throughout our history. Why we see that value? There are two reasons why we see the value. Because if you lead, from our point of view, if you are a leader in standard, you define the standard through your ideas, or at least you contribute in a great way to define the standard through your ideas, of course, as long as the ideas do have technical merit. And that also reflects positively in time to market for our products. So we are, of course, not the only ones to think that way, but we also think we are among the ones that have pioneered this way of thinking. Being a creator of standards also for us translates into product leadership. Obviously, being a creator of standards also means that our IP, our extensive IP portfolio, becomes more impactful, becomes more valuable. So that's another reason why we see the value in technology standardization. Also in this case, we are not really necessarily the only company that think that way, but we also regard ourselves as having pioneered this type of way of thinking. As I mentioned, we participate in over 200 global standards and industry organizations. Is our technology standardization operations in Qualcomm that I have the honor to lead is a large-scale operation, and of course we are very proud of that. Let's make some examples now. Without further ado, let's take two areas that everybody knows about and that also relate clearly to Qualcomm business. The mobile space, presumably everybody has a smartphone in the audience, and the automotive space, presumably many people have a car. So in a mobile phone, there are large number of standards get embodied inside the mobile phones. Obviously, people intuitively will think of 2G, 3G, 4G, 5G, in the future 6G. And that clearly is true. And there is, of course, a major standard organization that defines those technologies. Because sometimes it is not so well known that there's a whole ecosystem of other industry organizations that then takes care of regional aspects, regional certification, regional needs for those connectivity technologies, as well as device certification and testing. Same goes on for wireless LAN and for short-range connectivity, ultra-wideband, Bluetooth, Wi-Fi, all things that presumably are in everybody's phones. Same goes on for emergency calling and location services. Also, this area is governed by standards, technology regulation in different areas. And the list goes on and on. Many people, of course, maybe most people use phones to consume multimedia services of various kinds for productivity, learning, or self-entertainment. And obviously, there are standards around them too. Multimedia content is delivered through mechanisms that are themselves being evolving over time through standards, as I'm going to talk about later. And then even inside the phone, how the processor in the phone is connected to the display, how is it connected to the memory, how is it connected to other peripherals. Also, those connections, they come through standards. So within a mobile phone, there is a huge number of industry organizations that are, shall we say, represented inside the work of a mobile phone. Same would go on for automotive. So, and let me mention just two areas for the case of automotive. Increasingly in the automotive space, there is interest on car-to-car collision avoidance, collision detection. That's where V2X technology comes into play. Obviously, that is a standard that has some fundamental technology component coming from a standards organization, and then it has multiple other regional elements or software components that come from further from other industry organizations. So also in this space, the work of many industry organizations is reflected there. And then obviously there is a worldwide trend on assisted driving for automotive. Assisted driving, as like the entire automotive space, is heavily regulated. So there's a whole world of technology standards also for assisted driving. I mentioned this also to give an example that another highly technological object like the automotive, like a car that everybody is familiar with, also in that case, we see a presence of large number of technology standards. Let me now move on to the next segment, where I will try to give examples going one level deeper, and I will share also, of course, from the Qualcomm lens, what are the areas of technology standards that we regard as very important. This will not be an exhaustive list. Clearly, there are going to be other industry organizations that are also extremely important for Qualcomm that will not be represented here. So this is sort of a subset that we try to select to look into many different areas, trying to be somewhat representative, and that we thought could entice the interest of the audience better. But by no means this is an exhaustive list. So we're going to quickly talk about wireless communication, especially 3GPP and a little bit IEEE. We're going to talk about video, and we're going to talk about voice, and we're going to talk about memory. So let me first talk about wireless. People may know work on 6G standard has started. Probably in everybody's phone, you have 5G technology, as well as 4G, 3G, 2G. 6G is the next iteration in that continued evolution. Of course, the cellular industry is the paramount example of a successful standard. For those that are familiar with the history of cellular, cellular was not originally a global standard. Obviously, there used to be regional cellular standards, and then they started to converge into continental cellular standards until when there was eventually a single global standard, and that's the status that we've been having today, and it will be the same for 6G. So 6G work has now started in earnest. I will not spend too much time talk about 6G. I think also Qualcomm has recently done a number of other webinars with my colleague John Smith, for example, and others where we expand on the value proposition of 6G from our point of view. Of course, we can talk about that in the Q&A if there is interest, but I'm not planning to talk too much about that as part of the core presentation. What I wanted to talk about is more the standard organization that is working on 3GPP, which is an incredible human endeavor and should be celebrated. So this is an organization called 3GPP. Personally, I've also participated in 3GPP for a number of years. It's a huge organization with an incredible number of member companies, literally from all corners of the world, hundreds and hundreds of member companies. It's immense in scope with about 20 groups, highly technical in many different areas of technology. And we made an estimation of the cumulative meeting time that has occurred in the history of 3GPP and exceeds thousands of many years. So obviously a number that is even difficult to fathom. What we find particularly valuable and interesting and fascinating about 3GPP is that it's a totally member-driven organization. It's very bottom-up. So while, of course, companies participate and they are competing based on technical merit, and also you have, of course, competitors in the industry participating, it's a collaborative engineering effort. So it's an organization based on a bottom-up model of collaboration competition, which is really a unique aspect and that has worked very well for the industry. So we really like to talk about 3GPP from this point of view. Why also is 3GPP so complex? I think it's worth mentioning about that. Why is such a gigantic organization? This is because cellular systems are very complex, so different than other standards that I'm going to talk about in the remainder of the presentation, where the scope of the technology standardization is really just a single interface in some cases. 3GPP standardizes numerous interfaces because it takes care of the overall system. So, of course, everybody knows about the fact that the phone has to talk to some antenna and there is a wireless interface. But what is not always visible is that cellular system is much more complex, and behind the antenna there is a whole structure, there is an architecture, there are servers, not to mention that, of course, people can take their phone and go in another country and it still works. And of course, we're totally used that everything works. You go to another country, another continent, and so on. But all of this is because there is an enormous work of technology standardization behind the scenes, so that everything has a common base, which is in fact the 3GPP standard. And that's why 3GPP is such a complex organization, such a huge organization. Also, from this point of view, it is very unique. Of course, having been a major participant or having an incredible heritage of leadership in cellular communication, we are often faced at Qualcomm with the question of what does it mean to be a leader in 3GPP and so on. And of course, also personally, I've been very engaged in this sort of niche debate for a number of years. And it's always worth repeating that some in the past, maybe more in the past than today, have been asserting 3GPP leadership based on number of contributions, which in general is a concept that is very popular in some circles, so it's very easy to understand, but is equally incorrect. And of course, we really like that picture, is the same as considering leadership in sport based on ball possession or the quality of a painter on the number of paintings completed and so on. So like any creative act, you cannot really judge the value of the creative act through some quantitative measure of output. That, of course, would be naturally understood in any other creative endeavor. And of course, engineering technology in this domain is not different. So, of course, what we think, the way we like to see leadership and how do we see leadership in the area of communication, but as well as any area where we have technology standardization, and 3GPP is a great example from this point of view, is that we try to give ourselves a bar where we try to think of problems to be solved. We work on those problems before standards start. We try to validate our ideas through our work, and then eventually we bring those ideas in for HBP. HBP also has its own culture and working methods through which a standard is created, where individual contributions are never accepted or rejected. Is the ideas that live on. The contributions are simply the vector through which ideas are brought into the bloodstream of HBP, but are the ideas that live on, not the individual contributions. Also, very valuable thing for HBP is that everything happens through consensus, as I was mentioned in a previous slide. And so it's the ultimate group where peer-reviewed meritocracy takes place. So eventually, when your idea is accepted as HBP, it means everybody agrees, including, of course, your competitors. And that is an incredible measure of professional validation. This slide, in that regard, sort of recaps our long heritage, where, of course, our heritage would go even more to 2G and 3G, but we like to make it start from 4G. That's when wireless communication moved to OFDM or FDMA waveform. And it was a little bit of a little bit of a step function in terms of evolution of cellular communication, and that started with 4G. Many ideas from 4G or incubated in the 4G times made their way at the beginning of 5G, so they created a foundation of 5G, which is in release 15. Release 15 was the first release of 5G NR, and then they continued in release 16, 17. We regard ourselves as having been clearly a major leader, if not the leader, in the development of the 5G standard. And we see the evolution of cellular communication as a continuum. So while, of course, it's normal to refer to cellular communication through the generations, 4G to 5G to 6G, in reality, the work is really a continuum where there is this structure of releases, and then 5G had release 15, 16, 17, and then it moved to 5G advanced, 18, 19, 20. And this is like a continuous step function of improvements in different areas that then comes to fruition with the creation of a new generation that is 6G, which I said earlier is what is being worked on. In that domain, one area where I really like to put some attention, because also, of course, it's a great example of the attractive power of a successful standard in the area of satellite communication, which is also referred to as non-terrestrial network, or NTN. So we are really at a major inflection point for satellite communication, because all major segments of satellite communication in many different geographies in the world, they are moving towards adoption of the 3GPP standard, thus having a convergence of terrestrial communication and satellite communication. This is really an inflection point, because historically satellite communication has not been on the same bandwagon, shall we say, as cellular communication. These were two completely separate worlds for many, many decades, and we're really at a historical inflection point now. And this is a great testament of the work of 3GPP, which we are proud to have contributed to, that has really embraced an entire new segment and to adopt the requirements and to create technology that would fulfill the need of the satellite communication within the context of terrestrial. From Qualcomm point of view, I said we are very proud to have contributed to that effort. We've been leading a lot of that work. We also have a long heritage in satellite communication. We like to talk about that. Of course, Qualcomm itself was started around satellite products. Some people maybe don't even know about that. It's, of course, a long time ago. Omnitrax, Global Star, which of course exists today. Then the OneWeb project. And then finally, we see that as a sort of a continuum that has brought today to 5G NTN, which really is a variant, in fact, two variants of the 5G technology for satellite communication. And these two variants are, on the bottom, IoT NTN, which is NTN applied to IoT use cases, which in fact has already been commercialized. And the upper part, which is NR NTN, so broadband satellite communication to the phone with 3GPP technology. And this is the one where I mentioned as being an effort for many years. And finally, it's a very significant inflection point, where, as I said, major actors in the satellite communication have indicated in different contexts their willingness or their intention to migrate to 3GPP-based technology. The next step, next companion to, of course, to all of this, we talked about the cellular, we talked about satellite, and we're going to briefly talk about Wi-Fi. Also, in this case, very recently, another colleague of mine, Rolf de Wecht, has given a great webinar on the latest innovation in the Wi-Fi standard. So really, I also want to refer to his presentation for more details on what's been happening on Wi-Fi. Wi-Fi has gone through an incredible curve of evolution for a large number of years. Also in this case, we're very proud to have been leading a lot of the work on Wi-Fi technology standards evolution. And I just want to mention here a little bit for context how the work unfolds and also how our commitment to this work is represented. There are two major organizations that have been at the center of the work on Wi-Fi standard. One is IEEE 802.11, and of course that's where typically the technical work has been taking place, where the technology innovation has been happening. We have a long history of leadership in that domain. And then, so from this point of view, this is comparable to some groups of 3GPP. The Wi-Fi industry then is interesting in the sense that there is another major organization, which is the Wi-Fi Alliance, that doesn't have an equivalent probably in the cellular industry. Of course, these industries are different in their own rights. And Wi-Fi Alliance is really a technology ecosystem organization that tries to bring the core technology and bring it to market. So much more product-oriented, ecosystem-oriented, etc. And also in this case, Qualcomm has had a historically long commitment to Wi-Fi Alliance success, which also we've received several awards in that regard. From this point on, let me move on and talk about something else. I've been talking a lot about wireless, different types of wireless, cellular, satellite, Wi-Fi. There would be more, but of course, we cannot go on forever. So, I skipped some other wireless technologies. And let me talk about video coding. Video coding also is very important, very relevant to everybody's life. Why? Of course, large number of time consumed on mobile computing devices is consumed interacting with video, consuming video, getting educated, entertained, or for productivity or whatnot, and there is video involved. In fact, video is a dominant type of traffic, as everybody can intuitively appreciate. And video coding technology is therefore very pervasive and present a little bit everywhere. So the video technology, video coding standard is itself slightly fragmented in the sense that there is a core, a historical standard, and then there will be a couple of offshoots that I will mention later that come, but the fundamental technology path is the same. And the center of the world for technology innovation in video compression is the so-called JVET, the Joint Video Expert Team, that was created a long time ago as a collaborative effort between two historical international organizations for technical standards, ISO with MPEG, and the ITOT with the VCA, the Video Coding Expert Group. And so that's where the work has been, through the collaborative effort of these groups, that's where work on video compression standards has developed. But apart from that, why is any of that important? Very intuitively, we can just take the case of YouTube, which everybody, of course, knows about, and the video that people consume on YouTube is compressed. And what would happen if it was not compressed? If YouTube stopped compressing video, it's very difficult for us to make a very precise estimation, but based on a very reasonable estimation, you would need much more bandwidth than what the entire internet can handle today in order to carry the traffic. So just you wouldn't have YouTube as it is today without video compression. So video compression is really fundamental to the delivery of video content in any context. So it's a really very fundamental technology that is a natural companion of the wireless technologies that I mentioned earlier. It's very impactful to the existence of the products that we hold in our hands today. And we have a little bit of a historical path here. So just for people to this presentation is also, as I mentioned, a little bit educational. So for people to familiarize with the path of video codecs. And the first big milestone was about 20 years ago already with the video codec called AVC, video compression for AVC, later followed by the HVC, which is actually utilized in devices today, largely utilized devices, browsers, and so on, and then followed by VVC. And now the same organization is working on the next generation standard, which doesn't have a finalized name yet. It has a code name called H267. And let's see what is going to be the final name there. Each new generation has offered additional compression gain, which means the ability to compress more compared to the previous generation. So you can see every time it's been about 40% more compression than the previous generation, which means you can deliver more traffic with the same capacity, or you can use less capacity for the same traffic, obviously. In parallel, it's a very complicated industry. I will not go too much into these details, at least within the core presentation. There has been regional offshoots with variants, with other organizations creating variant codecs, let's call them like this, so VP9 and AV1, which also are deployed in the real world, but they use the same fundamental ideas. So at the end, each of these codecs, like I'm going to show in the next presentation, utilizes a number of features, and the fundamental technology that are underlying these codecs are pretty much the same. So whether you mix them up in one way or you mix them up in another. And then how do we look at our own work? How do we look at our own work? We have been leading, we regard ourselves having been led the work on video compression for a large number of years, both in the case of HVC and in the case of VVC. And as I mentioned, each of these video codecs is an aggregation of what is called in the industry, aggregation of tools. Other people would call them features. So you have a combination of a number of features, and the combination of these features provides the compression of video content, the so-called compression gain. And you indeed can associate individual features to a certain amount of compression gains. So each feature or each tool is not equal to every other tool. There are tools that provide much more compression gain than other tools. Of course, this is somewhat objective and is even documented in these standards organizations. And therefore, of course, you can associate the contribution that each company has done to a certain share of the total. So if the total of the compression gain is about 100%, then you can see how much each contributor has given to that share. So who has contributed what and so on. So for example, as Qualcomm, we associate our work to some tools that have provided huge amount of the total in case of HEVC. So in some case, one tool that has given 20% of the overall gain comes just from one tool that has been coming from our work. And this has been even more pronounced in the case of VVC. So in case of VVC, also we think that we have been contributors, initial contributor or main contributor of tools that overall account for 80% of the total. So that's a way to measure leadership in video coding from our perspective. Video coding standards, as mentioned, they are somewhat differently organized than wireless standards because compression is more, some people call it a 2D function. because it's written on a single interface and you have some content and you're trying to compress it. So you don't have the complexities that I mentioned earlier of roaming or system architecture and so on. Is a simpler architecture, if you will, and therefore it also, in a certain sense, simpler to identify leadership or to associate one's work to actual gain that translates into product value. So that's for video coding. Of course, another major aspect of multimedia that everybody is familiar with is voice or speech. And also speech has been seeing a lot of work in areas of standards for speech coding. And why does speech coding exist? One can think, because of course we are in an era of abundant bandwidth, and at the end, voice doesn't occupy so much bandwidth. But the reality is that, first of all, of course, it was not always the case. So there's been a long history of speech coding innovation that also in this case we want to talk about, but is still relevant today because, first of all, mobile systems are complicated and not always you have abundant bandwidth, and sometimes you're at the cell edge or your coverage is not good and you are trying to speak, and speech coding is a very significant contributor to the user experience. So effectively, even though from a certain perspective speech is not such a big contributor to the overall bandwidth consumption, is a big contributor to the user experience, so how people experience their products or experience the overall technology of mobile computing. And therefore, because they can improve a good speech coding solution can improve coverage. Of course, also for over-the-top voice apps that people use today. Not to mention that there are, let's call them relatively niche use cases like public safety communications, emergency communications, conferencing that are all based on voice in different twists more than, let's say, the general consumer usage of mobile computing. This is a little bit of a history of our work on voice coding, and there's been 3 milestones. We look at it, of course, could be more complicated, but we see 3 milestones of Qualcomm's own commitment to this area. We started to work in a major way on speech coding long time ago, 20 years ago, around the times of CDMA, with EVRC family of voice codecs. And at that time, the focus was capacity. So back then, the focus for mobile systems was to have more capacity, to be able to support more voice calls. Of course, it was a long time ago. Another milestone happened when mobile systems, first of all, converged on a single global standard that was LTE, and simultaneously, circuit switch was abandoned, and therefore all voice started to be treated like data, which introduced some more challenges in terms of link budget. And therefore, voice codec evolution had to help to overcome link budget challenges. And that's when new voice codec was invented, called EVS, that we'll talk about later, which is another proud moment of our history on technology standards. And then the story is not over, because I talked earlier about satellite communications, and satellite communications does introduce new challenges in terms of delivering voice for somewhat obvious reasons, because you're talking for connection to a satellite in the sky. And now you have to overcome issues both of capacity and link budget. And there is a project ongoing right now for a new voice codec in that sense. So EVS, I mentioned earlier, is massively used today, is the gold standard for mobile voice, is a multifaceted codec. So it's a voice codec that has what in the industry is called different modes. Why there are different modes? Because there are different trade-offs that can be executed in the area of voice. So you can have much higher quality, consuming a little bit more bandwidth, or if you're bandwidth constrained, you can have acceptable quality. So a voice codec is an exercise in trade-offs to try to play with different dimensions, how to adjust to network conditions, and how to deliver wideband voice. So also in this case, as I mentioned earlier, voice is a big contributor to user experience and to being able to communicate clearly, to appreciate the richness of sound and the richness of the human speech. So as I mentioned earlier, it's a multifaceted codec, and we had major contributor in many of these blocks of EVS. It was really a great moment for Qualcomm and for the Qualcomm team in this particular domain, especially because this codec is now massively used pretty much everywhere. And the next chapter in the history of voice codec standard, as mentioned earlier, is the ultra-low bitrate codec, ULBC, that is being introduced for satellite communications. And that is going to address a number of different use cases or challenges. Of course, you can see in the picture, nice fellow that is hiking in beautiful location. And there is also tremendous interest in the industry, as mentioned earlier, on satellite communication, especially when coupled with voice, because now, and especially when coupled with the convergence with terrestrial communication, because now really you can enable mobile computing, mobile connectivity everywhere, also where terrestrial coverage does not occur. And in some cases, that's where to have a voice connection is more valuable in case of emergency. And then last but not least, let me talk 1 or 2 minutes about standards, technology standards in another area that does not include wireless, that includes only wires. And we really wanted to talk about this area because it's very relevant in today's world, and because also we wanted to make sure the audience to appreciate how technology standardization and the dynamics I've been describing so far, and thank you for bearing with me up to now, they apply not only in the world of wireless, but they do apply also in the world of wired connectivity. So why memory? Why there are technology standards in memory? Because, as again, maybe people can appreciate intuitively, memory tends to be a discrete element, and memory is present in every computing device. And often what you have, and actually not often, but pretty much always, you have an interface between processors and memory. And that interface is standardized. And that interface does evolve through exactly the same dynamics that video coding or Wi-Fi or cellular communication evolves. There are new requirements, there are new industry needs, there are new consumer product needs, and they translate into new requirements into this standard. The standard specifically is JEDEC, and this is just an example of this particular standard for memory for mobile computing. The key term is LPDDR, and this is just one single chart that makes you appreciate the tremendous amount of progress that has occurred in 20 years in this particular standard, that also Qualcomm is being a very significant and major contributor. Big increase in energy efficiency, so being more efficient in energy consumption, while at the same time massively increase the bandwidth delivered over that interface. So again, in that sense, is the same mental model as for video or for wireless, being able to do more with less, which is kind of the fundamental framework, if you will, of many of the standards that I've been talking about today, being able to do more with less through the power of technology and through the enabling power of technology standardization. Memory has become very important today in the era of AI, as you have to shuffle bits back and forth from the processor to the memory. And that's why also you see this curve continuing going up even in the latest generation of the LPDDR standard. As I mentioned today, and I'll conclude very soon, is we have a long history of leadership also in this area of standard, because it's very important. It's very important for all areas of mobile computing. And I would like also to mention we had a very proud moment this year when Qualcomm, and in general the Qualcomm team involved in memory standards, was awarded an executive award delivered to our CEO, Cristiano Amon, by the JEDEC board of directors, where actually we also are on the board of JEDEC, obviously. So this was also a great moment, great recognition for Qualcomm to its contribution in the world of memory standards. And with that, I would like, of course, to thank everyone for listening up to now. Just to recap what we've been talking about today, We've been talking about how technology standards are the backbone of intelligent computing. We explained why. We explained why standardized technologies exist, why they unlock value, where the value comes from, and then we've been giving a number of examples of how that value comes to existence in different domains, from connectivity of various types, from multimedia of various types, and even in wired connection. And thank you all for the attention up to now. And Andrea, back to you. We have some time for Q&A.
All right, we will move on to the Q&A. Thank you so much for that presentation, Lorenzo. So if you haven't submitted your questions yet, please do so now. We'll jump right into the questions. So our first question here, what are your thoughts on AI standardization? Does it even make sense to standardize it?
Yeah, no, AI as a core technology doesn't get standardized because AI is a set of algorithms, and in itself, AI is not getting standardized. There are, however, initiatives of technical regulation in the world of AI and standardization efforts around the world of AI behavior. So let me give a couple of examples in that regard. There is a very prominent organization called ML Commons, where all the big names in AI are present. There's also Qualcomm, but also all the big companies that everybody knows about, from Google, Meta, and so on. They are in ML Commons, and ML Commons is an industry initiative that they've been working on two areas. One is to create benchmarks for the performance of AI, and the second one, very importantly, to create safety standards. So there is a big topic in the public conversation outside of the technology world about human beings interfacing with large language models and asking questions and having an actual, even a relationship, a sort of a pseudo-human connection with large language models. And how should that be governed? So how should we look at AI as you talk to AI? Should that be governed by some safety elements, some guardrails? And this organization has been trying to create standards in that domain. So just to recap, there is no standardization for the core technology itself, but around the behavior of AI, yes.
All right, another question. How is AI being treated or standardized in 3GPP or IEEE?
Oh, very good. It's a very good question. I think AI is an underlying technology. So also in this case, AI is going to be pervasive in wireless communication. Also in this case, it's not like there is a standardization of AI per se, but it's just that it's pervasive in all of the process. So let's make a few examples. You're going to have AI improving algorithms that govern wireless connection. That is going to be somewhat more hidden from the standard, but the standard will presume the usage of AI for its functionality. That's one case. Then there is a whole area, as I mentioned earlier, 3GPP also does a lot of work in the hidden part of the cellular system, the one that as consumers we do not see. So how the cellular operators manage their network. That whole system of network management will be massively improved by the usage of AI, obviously, because it's a complex system, and like any complex system that is governed by a set of rules, AI can greatly help in the efficiency there. So in that case, there are big standards being created. Is the area called SMO or ONM for people that like acronyms. And there is work on standards in that domain that will use AI. So that are just two examples of usage of AI in cellular systems, wireless systems.
All right, next question. Considering the fragmentation in the satellite market, do you see a future role for 5G NTN?
Yes, absolutely. Very good question. Yes, it is very correct that today the satellite market is very fragmented. I mentioned in my presentation, I do believe we are at an inflection point. There are major satellite companies, including the ones that people know about. They have indicated in public ways, for example, with documents in 3GPP, that they will intend to migrate to 3GPP technology. So that is the case, for example, of SpaceX or Viasat. But then also there's activity in China and in Europe with new constellations and clear indications also that in public setting that these new constellations will have to be based on 3GPP technology. So the fragmentation today is true, but the direction is also very clear that the direction will be of a convergence to 3GPP technology. Of course, it will not be from today to tomorrow because the satellite industry, by definition, is slow because somebody has to launch satellites in the sky, which is complicated, but it will happen. The direction is very clear.
All right, next question. What are some of Qualcomm's contributions to ULBC?
I think there are two major areas that we look at ULBC as where we can contribute. One is that this new voice codec will make use, in our opinion, will make use of AI. So we'll introduce new fundamental techniques on how voice is compressed, is decompressed. So that's one area where we feel we have really something to contribute, really something to say and to prove. And then the second area is that this codec for ULBC that will have to deliver voice with satellite connections in extreme connectivity scenarios will require much more joint work between understanding the radio and understanding voice. And I think in this particular intersection also we have something valuable to bring to the table.
Another question, could you provide examples of how advancements in LPDDR or UFS standards are contributing to more efficient AI processing in mobile devices?
Yes, so in this particular case, for AI processes that maybe people are familiar with the concept that is mentioned sometimes of memory wall, which is the performance of AI from a consumer point of view. Sometimes is capped not so much by the performance of processing or performance of computing or even performance of connectivity, but by the performance of the transfer of data back and forth from memory. That's why people call about memory wall. And so that's where, at least in the mobile context, that's where the LPDDR standard is bringing improvements that, of course, we are contributing to in a major way. It really brings very tangible value. So in the area of bandwidth, so increasing the bandwidth between the memory and the processor is where really we're bringing something to the table that has a tangible effect on end products.
Another question, how do you see the AI deployed to low layers of RAN? Do you see it more as a continuity in the current standards or as a real disruption?
I see it more as continuity. I think it relates to the earlier question. AI will be an underlying technology that will make everything better. So the standard for wireless will continue to have, in a certain sense, similar look and feel, but it will presume that AI is used for a number of functions, and therefore it will end up working better because for a number of functions it will be presumed that there is some sort of automation or self-learning. But the general structure of the standards will, in my opinion, will continue to remain the same.
Another question, what is the future of non-3GPP interworking functions for FWA and fiber?
That's a good question. It's interesting because I think it will continue in the case of fiber. In the case of fiber, there will be I think there will be a natural continuum. There is some interest, of course, in the industry or for certain operators that have both fiber assets, so wired assets with cable optics, etc., and wireless. There are already solutions today where basically the standard defines what is called a common core network for those operators, such that they can manage home customers and mobile customers in sort of a joint way. think that will just continue. It's not something that gets revolutionized, in my opinion. It's something that gradually gets improved. For fixed wireless access, kind of different, because fixed wireless access is really like a new area. It's a new area where effectively is mobile communications. In a conceptual, you can see it's similar to satellite, in the sense that now it's an area where instead of using dedicated technology, gradually there will be more and more usage of 3GPP based technology because of economy of scale. And then also in that case, we already see now in some geographies great uptake of fixed wireless access in the case of 5G. So I think also that will continue. If anything, 6G will try to be even more attuned to the requirements of fixed wireless access, because it has emerged as an important use case.
Next question. Curious about how to converge different standards in different areas to reach an all-agreed standardization.
Oh, that is, of course, one of my favorite questions. So how people converge in these areas. And I think it's, what I like to say, I've been saying in many contexts in the past, that technology standardization is, yes, an engineering activity, and is a technology activity, and is an activity where large corporations are engaged, but ultimately is also a human endeavor. So eventually, it's human beings talking to each other and finding an agreement. And so from this perspective, while of course, the nature of the operations of technology standards is extremely technical, at the end is human beings talking to each other. And is like any other area of life where human beings try to talk to each other and to find a common solution to a problem. In general, what is important is that people have a shared sense of identity, or a shared sense of trying to solve a problem. And if that is the case, that everybody agrees that we are trying to go from A to B, but there are many different ways to go from A to B, through dialogue, usually you find a solution.
Another question. In which standardization organizations is Qualcomm contributing to the development of broadband connectivity through LEO satellites and distributed processing?
I would say that is 3GPP. So in 3GPP is where the work is happening, as I mentioned earlier, for satellite communication that, of course, uses 5G and 6G. In that regard, I think I mentioned earlier, 3GPP has an incredible number of members. In fact, we could have had even more slides. 3GPP has had a massive growth in the number of members. It used to be only telecom companies, or companies like Qualcomm or Verizon or China Mobile or Vodafone participating in, or Ericsson participating in 3GPP. But now, out of that, those hundreds of members, we have dozens and dozens of satellite companies participating in 3GPP. So effectively, 3GPP is also, by all means, a satellite technology standardization body.
All right, so we have just over 1 minute left, so we have time for one more question. For entities currently behind in standards engagement, what top actions do you recommend to jumpstart engagement, ensuring a voice in the future of standards?
Well, what I would recommend is to try to get structured. So we get this question, of course, when we meet smaller entities, or we meet governments, for example. The solution in general is to have commitment. So if you're a corporation, if you're an entity, or if you're a small company, or you think you can get value and you want to contribute, you need to start to create a team, allocate some people to follow standards in a dedicated manner, and then from there grow. So just go there, learn, and then gradually start to participate. At the end, that's also what we have done as Qualcomm.
All right, so that's all the time we have for today. If we were not able to answer your question, we'll do our best to follow up after today's webinar. As a reminder, a recording of this session will be available on demand within 24 hours. Thank you for joining us today, and we look forward to seeing you next time.
Thank you.